All right, I put these last two examples on a separate video because they're a little more involved, and they kind of include all three steps of solving our equations. So we've been isolating variables, we've been moving variables in that last example in the last video, but now we are going to also add the simplifying. Okay, so here's what's going on. When I look at this problem, I have a side that can be simplified using the distributive property, okay? So the first thing I'm gonna do here is I'm gonna distribute a -4. -4 times 2x is -8x. -4 times -1, some of you are still making that mistake. That is a -1. It's not minus and a 1. Y'all gotta stop thinking that way. I mean, it is, but it's also a -1. So -4 times -1 is +4. This is an easier expression to work with than that one, okay? That's what's happening, is we want to make this equation as easy to work with before we actually start really working with it. On the right-hand side, I can also distribute. So I'm going to distribute a 10. I get 10x minus 50, okay? So we're good so far. Simple distributing. We did that earlier in the week. Now, my next step, I've simplified both sides. There's nothing else I can do, right? 10x and 50 aren't like terms, so I can't combine them. Now I've got to move my variables together, okay? So I got to move either the -8x or the +10x. I said in the last set, move this smaller one. -8 is smaller than 10. So what's the inverse of -8? That is to add 8x to both sides. It's going to cancel that completely out, and I'm left with +4. You don't have to put the plus there, okay? 10x plus 8x makes 18x. Whoops, minus 50. Now you've got a pretty familiar looking problem here, okay? So I'm going to add 50. 4 plus 50 is 54. And 18x is left over here because that canceled out. Then I'm going to divide by 18. And look, if you don't know how many times 18 goes into 54, go get a calculator. Don't spend more than like 20 seconds on that. In fact, 20 seconds is probably too long. Like 15 seconds, okay? At this point, we're checking to see, can you distribute? Can you move variables? Can you use inverse operations? Can you solve? If it's a simple math problem, then yeah, you should know what, if it was 18 divided by 2, I would expect you to do that by hand. But anything that gets any much higher than that, I'm okay if you just punch it into a calculator, okay? All right, 18 goes into 54 3 times. That cancels out and you get x, okay? So all we did from here down, it was stuff we'd already done. From here down, it's stuff we've done on every single example so far. We just added that you had to simplify it at the beginning, okay? So let's look at one that is maybe gonna look a little bit scarier, but it's really the same steps. Yeah, it's long. I tried to warn you. So here's what we get. First, I'm gonna simplify. This side in class, a lot of people struggled. They didn't think it could be simplified at all. Well, when you're combining like terms, if it doesn't have a variable and something else doesn't have a variable, they can also be combined. So I'm going to take this +7 and this -10, and I'm going to combine those. And a lot of people were having issues because they were thinking, well, it's 7 minus a -10. And they were trying to add them together. Guys, this minus is attached to the 6x. So if it helps you to view this as plus a -6x plus a -10, rewrite it that way. That's okay. I'd like you to get to where you're not needing that, where you can just view it as a -6 and a -10. But if that's where we are, that's okay. So 7 plus -10 is -3. And then you've got a -6x. I personally don't like this little double symbol here with a plus negative, so I will always just write -6x Is there anything else I can do to simplify that up? No, they're not like terms. There's no distributing. You're good. On the right-hand side, if I see parentheses, I'm automatically checking for the distributive property, which this does have. 4 times x is 4x. 4 times 6 is negative 24, or 4 times negative 6 is negative 24. And then I'm just going to pull these other pieces straight down because I'm only doing one thing at a time. Okay, if I showed work here, then I don't want to be trying to do extra stuff. All right, here, what can I still simplify? Well, I can combine 4x and 3x. That makes 7x, okay? I did not use an inverse operation. One of the issues that I see a lot of people do, and this is wrong, don't do this, I'm going to erase it in just a second, is they go, oh, subtract 3x, subtract 3x. Why do we do things twice? Okay, why would we ever even like subtract 3x, subtract 3x? Well, it's because you're trying to balance out this equation. You do it to one side of the equation, you do it to the other side of the equation. The problem with how we've written it here is you're doing it twice on one side, but not at all on the other side. So that's kind of a clue to you. If you do it twice, and this is why I draw the line down the middle, if you do it twice on one side, you're like doubling up negative 3's over here, but you haven't put any of them over here. So that is wrong. Don't do it. If you're staying on the same side of the equation, you just combine them. Positive 4 and positive 3 makes 7x. Same thing, this negative 24 that doesn't have a variable and this negative 5 that doesn't have a variable, you get negative 29. Okay? So this side, I'm just going to copy it down so everything is nice and lined up. Can I simplify either side anymore? No. So now I'm going to move my variables together. You've got a negative 6x and a positive 7x. The smaller out of those two is the negative 6x, which I'm going to cancel out by adding 6x. Those cancel. I'm left with negative 3. 7x plus 6x is 13x, and then minus 29. Now I can go ahead and isolate this variable right here. So I'm going to add 29, the same exact steps we've been doing over and over and over again. Clear out the addition, subtraction before you clear out the multiplication. That gives me 26. 13x, because this canceled out. Divide by 13, and you get 2. Okay? So this problem looks huge and nasty, looks impossible, like you could never do it. But it's really just a series of a whole lot of really simple steps, okay? This is the type of problem that makes you look extremely smart, but you and I both know it's just a lot of really easy steps done over and over and over again. So go show it to a little brother or sister and freak them out.